So our focus at the end of this unit is to bring everything together, and we're going to solve multiple angle trig equations. And we have a series of strategies here depending on the problem that you're given. So first of all, if the coefficient of theta is between 0 and 1, meaning you have something like theta over 2, which is the same thing as 1/2 theta, or 1/3 theta, which is just another way of writing theta over 3, or maybe theta over 5. Again, coefficient between 0 and 1. There is no generalization, and we've done generalizations before, and it's just based on the number of revolutions that we would have around the unit circle. And what you will have here is the fact that there will be less answers than an equation with just theta. Okay, so that's 1. If the coefficient of theta is greater than 1, meaning you have something like 2 theta or 4/3 theta, then you are required to provide a generalization, because there will be more answers than just an equation of theta. So we're going to talk about two different types here. One is if you're using sine, cosine, secant, and cosecant. There's a specific type of generalization you have to have, and this is where you will add 2 pi k, okay, where k is equal to some integer representing the number of revolutions. And then you just have to keep in mind that the generalization will include all angles between 0 and 2 pi. And remember, this is for sine, cosine, secant, and cosecant. So this is definitely a very important piece of information, because when we solve for tangent and cotangent, the generalization is to add pi k, again, where k is equal to an integer. And you'll only need the generalization for all angles between 0 and pi, and I've written down why here. So if you have an angle in quadrant 1, then that means there's going to be another angle in quadrant 3 for tangent and cotangent, because if you think about it, tangent is positive in quadrant 1 and positive in quadrant 3. And then if you have an angle in quadrant 2, then it will also exist in quadrant 4. Okay, so because tangent and cotangent are negative here and here. All right, so what we're going to do is take a look at a series of examples. And the first one we're going to deal with is the tangent, and I'll show you the repeats. But the biggest piece here is that you need to keep in mind when we solve these equations, we want our angles between 0 and 2 pi. Okay, so anything greater than 2 pi, we're going to eliminate. So the first thing I want to do is make a let statement. So to make this easier to solve, I'm going to say let x equal 2 theta. I'll be putting that back in later, but I'm going to make this easier for myself to solve. So we're saying that the tangent of x is equal to -1. And remember, based on the generalization for tangent and cotangent, we only care about the angle between 0 and pi. So in this case, what we're dealing with is x being equal to 3 pi over 4. And our generalization is plus pi k. Now, if we're talking about all the angles, I'll show you why we only need to go from 0 to pi in this first problem, but then I won't do it any further. The other angle would be x is equal to 7 pi over 4 plus pi k. Okay. So now I actually need to solve for what theta will be, so I need to resubstitute 2 theta for x. So we have 2 theta is equal to 3 pi over 4 plus pi k, and 2 theta is equal to 7 pi over 4 plus pi k. So now what we have to do is solve for theta in both of these, which means we're going to divide by 2, or basically multiply by 1/2. So theta is equal to 3 pi over 8 plus pi k over 2, and theta is equal to 7 pi over 8 plus pi k over 2. Okay, so in order for me to find out what my angles are, I need a common denominator here for this generalization. So for whatever that integer is, the number of times I'm going around the unit circle, I need a common denominator. So I'm going to multiply by 4 over 4, and 4 over 4 here. So what I get for theta is 3 pi over 8 plus 4 pi k over 8, which you see reduces. Okay, theta is equal to 7 pi over 8 plus 4 pi k over 8. So now this is going to help me get my angles. So remember, we don't want anything beyond 2 pi. So when we're dealing with 2 pi, and right now we have a common denominator of 8, we do not want theta to be less than 16 pi over 8, which is 2 pi. I just got a common denominator, so I know what value I'm looking for. So now what I'm going to do is create a table, and this is how we're going to choose what our angles are, and this is also where you're going to see that there are repetitions. Okay, so we'll create our table, and on the top we're going to put our k value, our integer, and on the bottom what angle or angles this will create. So let's say k is 0. We're going to start with 0. When I plug in 0, basically this goes away and this goes away. So when k is 0, I have 3 pi over 8 and 7 pi over 8 as my angles. So 3 pi over 8 and 7 pi over 8. And I'm still within less than 16 pi over 8. So now I'm going to have an integer of 1. So when I plug in 1, this becomes 4 pi over 8. So when I add these two together, I get 7 pi over 8. And then here I get 11 pi over 8. So now we need to keep going because this is still less than 16 pi over 8. So here I have 8 pi over 8, so this is 11 pi over 8. Plug in 2 here, 8 pi over 8, so this is 15 pi over 8. And I'm still good to go. So now we go to 3. Plug in 3, so this is 12, so this is 15 pi over 8. And then here this is 19 pi over 8. Okay, so I was looking for 16 pi over 8, and you notice here this is 19 pi over 8, so this actually goes too far. It goes beyond 2 pi, so I'm going to reject this. In addition to that, you can now see that I do have repeats. So when you give an answer, you do not need to repeat your answer, so I'm just going to take them from this first one, which I said fell between 0 and pi, and even though these exist, there are repeats, so I'm not going to use these answers. I'm going to use 3 pi over 8, 7 pi over 8, 11 pi over 8, and I stop at 15 pi over 8. So when I give my answer, this is how I list it. Theta is equal to 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. So these are my answers.